Today we are going to learn graphical representation of trigonometric ratios. Up to now we learned trigonometric ratios, how we derive the trigonometric ratios and angles of trigonometric ratios and system of angles. Now we are going to learn today graphical representation of trigonometric ratios. If you take sine theta, first is for 0 degrees 0, for 90 degrees 1, 180 degrees, that is 90 plus 90. Ratio changes, cos 90, it is also 0. Next, for 270 degrees, 180 plus theta, 180 plus 90. So sine 90 only comes. So it is third quadrant, minus 1 comes. Next, for 360 degrees. So for 360 degrees, 270 plus theta, cos 90. Again it comes 0. So this we can represent as 0 degrees, pi by 2. This is a pi. This is a 3 pi by 2. 3 pi by 2. And this one is 2 pi. So now we will represent a sine function on the graph. So for functions, f of x is equal to or y is equal to sine theta. F of x or y is equal to sine theta. So for this f of x or y, we consider on y axis and theta value on x axis. So this is x axis, sorry, and this is y axis. So it is origin, it is 0. So from this, this is 1. So I want to draw here. I need a place here. Please observe. Okay. X axis, y axis. So from this radius vector P, OP. So you have 0 degrees, 90 degrees, 180 degrees, 270 degrees, again 360 degrees after complete one rotation. So this is theta. So now this I am going to link to the graph. X axis, y axis. Now careful observe. Sine 0 is 0. Next step, sine 45 degrees. Suppose it is 45 degrees. That is 45 degrees is 1 by root 2. 1 by root. Sine 90 degrees. Sine 90 degrees is 1. This is 1. Here 270 degrees, minus 1 here. So sine 0 is 0. Sine 90. So somewhere here comes here. 90 degrees like this. Here 90 degrees. It is 180 degrees. On the x axis we have to take the angle. This is 270, 3 pi by 2. This is 2 pi. Okay. So one complete rotation we will represent on the graph. So first you see sine 0 0, sine 90. Sine 90 is 1. 1 here I will know 1. So sine 180 degrees 0. Next 3 pi by 2, 270 degrees. Sine 270 degrees means it comes here 180 over 270 degrees. So here minus 1 comes here, minus 1. Again 360 degrees, 2 pi radius. In radius 2 pi and degrees 360 degrees. So again it comes here, this point. Now join this one. Okay. One complete cycle. One complete Sine function is. Don't make sharp curves like this. We have to draw. So this is the sine function on the graph. On the x-axis, we have to take angles. Along y-axis, we have to take the values of the sine function. That is y is equal to sine theta. The ratio values here. So 45 degrees here somewhat you will get this value is also 30 degrees of 1 by 2 comes. 30 degrees, 45 degrees like this. This completes the one wave function, sine wave function. Is it clear? Next step, we are going to represent for cos. Graphical representation of cos. So if we take cos theta, cos 0 is 1, cos 90 is 0, cos 180 minus 1, 270 0. So cos 1, it starts from 1, for 90 0, and 180 minus 1, 270 0, and here coordinate cos is there, no, plus 1 comes, plus 1, this is plus 1. So now this function f of x is equal to y is equal to cos theta. So if you take a cos function on the graph of this one, so now carefully observe how it comes. First, cos 0 degrees. What is the value? Plus 1. Here it starts 1. Plus 1. Next, cos 90 degrees. Pi by 2. So 90 degrees 0. 90 degrees 0. Okay. Next, cos 180 degrees. Minus 1. 180 degrees minus 1. Okay. This one is for this one, only for sine I represented that. Okay. Next, 270 degrees. 0, 2 pi plus 1. So now if you observe, join this curve, minus 1, 0, 1. Like this it comes. Okay. Otherwise we can extend like this. It will extend it so long. Yeah. This is the graphical representation of cos on graph by taking their period from 0 to 360 degrees. That is 0 radians to 2 pi radians. Okay. Now graphical representation of tan we will take. In tan we will get y infinity, that you carefully draw that one. So now I am going to take the graphical representation of tan. So rub this one in this curve. Okay. Now for tan we are going to consider tan theta. This value is also rub it. Tan theta. For tan theta, for 0 degrees 0 to 90 infinity or 9 not defined. So for 180 degrees, it is again comes to 0. And 45 degrees 1 will come. 45 degrees also we have to consider here to get 1. 45 degrees. Okay, we will see. Next, 270 degrees. 270 degrees minus infinity, and 360 degrees again 0. 0 we won't get in minus, no? So now carefully observe, tan 0 is 0 here. Next, here we take 1. 1, here we take minus 1. Tan 45 degrees, somewhere you will get no 45 degrees, 1 will get 90 degrees infinity. Wherever we get infinity, draw a parallel line which is parallel to y-axis. So this curve will goes like this, infinity. Okay, this is 45, tan 45 is 1. Again, here sin 90 is infinity. Sin 90 is infinity. 180 degrees, 0. 180 degrees is 0. This is 0. Next, 270 degrees is, here we get infinity now. So infinity to goes like that. Okay. Again here also same thing will come. So you see 0, 1, infinity, infinity, minus 1, 90 to 180 degrees, minus 1, 5, 180 degrees, 0. Next plus 1 here. Somewhere you get plus 1 here. Infinity. So again, simply write infinity, don't write infinity. So next, infinity to minus 1. In fourth quadrant, tan is not there, 0, and again it goes to infinity. So this is the tan graph representing on the coordinate axis. So here y is equal to f of x is equal to y is equal to tan x. It is a function in tan. Tan instead of x we are taking theta no angle. So this is the representation of tan on the graph. Okay. Next representation of cosecant on the graph. So values of cosecant we will see here. What are the cosecant values? Cosecant theta. Cosecant 0. It is reciprocal of sine. So cosecant 0 is 1 by 0, sine reciprocal of 0, infinity. Next cosecant 90, 1. Next cosecant 180 degrees. 180 degrees means what will come here? 90 plus 90. So 1 by cos 90. Cos 90 is the ratio does not changes, ratio changes no. For sine 180 degrees. Here 0 will come 1 by 0. For 90, 1 will come. Sine 91, 1 by 1. Sine 180 degrees. So infinity will come. Next here 270 degrees. So here 1 come, minus 1. Here infinity. Okay. This is the cosecant values for 0, 90, 180, 270 and 360 degrees. So we will represent on graph. After a graph, the x-axis we have to take angles and y-axis we have to take function. That is y is equal to cosecant theta. That is nothing but f of x. So now it is 0. Here 90 degrees, 180 degrees, 35 by 2, 25. So now cosecant 0 is infinity. Cosecant 0 is infinity. Somewhere infinity will come. For 91, here 1, here we take minus 1. So infinity means, so like this it comes, infinity to 91. So again 180 degrees it is infinity. So like this it goes. Okay. Next step, Cosecant 180 degrees infinity, we have minus 1. This is infinity, 180 degrees. For 270 degrees, it is minus 1. And again it goes to infinity. Like this it goes. Here also it comes like this. Okay? Here it comes like this. If you extend the angle this side onwards. This is the graph of the cosecant. Next graph of secant we will see. Secant theta. So of this one. For secant theta what we get? That we will see. Secant theta. It is the reciprocal of cos. Secant theta. Secant 0. What is the secant 0? So, secant 0 degrees. It is reciprocal of cos. Cos 0 is 1 by 1. Okay. Next secant 90 degrees. Reciprocal of cos 1 by 0 is infinity. So, this is a minus 1 infinity. So 1 minus 1 infinity plus 1. Because it falls in fourth quadrant, near the fourth quadrant it touches, plus will come. So now careful observe where you will get infinities at 90s. There you draw a dotted line at 90s and 270 degrees also you are getting infinity. No? Here also you draw a dotted line. So now careful observe. Secant 0 is 1. 0 is 1. Next 90 degrees, it is infinity. Okay. Next, secant 180 degrees, minus 1. This is minus 1. So infinity to minus 1. And 90 degree, 270 degrees, infinity. Okay. So next, 360 degrees, 1. Infinity to 1. Again this graph goes like this. If you construct further, here also if you construct further, it goes like this. This is the representation of secant data on the graph. So y is equal to secant data. So for this value, this is secant data graph. Okay. Next, cosecant data. Cosecant theta.
Already finished cosecant.
Cosecant theta was over now already. Next cot theta. Finally cot theta. Cot theta. So cot theta. For this you have to drop all these values. Now for cot theta on the graph where the cot becomes infinity, that you have to carefully observe. It is reciprocal of tan. It is reciprocal of tan 1 by tan theta. So tan 0 degrees is 0, 1 by 0 is infinity. Tan 90 infinity 1 by 90 is 0, and again it comes infinity, 0, infinity. So where you will get infinities? At 0 you will get infinity, and 180 degrees you will get infinity. There you draw the dotted lines. Next 360 degrees. So now carefully observe. So 0 is infinity and 90 is 0. So infinity, like this it comes. 90 degrees is 0. Here in between 45 will come, 45 1 you will get. Next 90 to 180 degrees. In second quadrant there is no cot and tan. So for 135 degrees here comes minus 1 here. Minus 1. And again it goes to the infinity. Okay. This is the graph, comes like this. Okay. Next step, 180 degrees, infinity to 0. Infinity to 0. Here 180 between 270. So cot is there in third quadrant. Plus 1 for 180, 225 degrees. Plus 1 will come. Again, it goes like this. It is minus 1 here comes. So this graph continues like this. If we extend like this comes. This is the graph of cot. Carefully observe, take the screenshot. So now we finished representation of trigonometric ratios, 6 ratios on the graph.